Hello, welcome to the second video, and we'll start here with number 9. So if I'm solving this trig equation, a lot of the time, in order to solve a trig equation, we need everything in terms of the same trig function. And so the question is, should I replace cosine squared or sine of x? Well, because cosine squared reminds me of the Pythagorean identity sine squared x plus cosine squared x equals 1, I know that cosine squared x is really the same as 1 minus sine squared x. And then if I add sine x and set that equal to 1, now everything is in terms of the same trig function. So what I can do is get everything on the same side. So what if I moved the 1 to the other side? I would have negative sine squared x plus sine x equals 0. Now, because I have a squared function, and they're both the same trig function, we could maybe consider factoring. And the like term between the two, and I'm going to take the negative out as well, is negative sine x. And when I take that out, I'm left with sine x. And then if I take a negative sine x out of sine x, I'm left with minus 1 equals 0. Now I can use the zero product property to set both of these pieces equal to 0. So I would have negative sine x equals 0, and I would have sine x minus 1 equals 0. And so I would solve them separately. If I divide by the negative, I would have sine x equals 0. And so what we're looking for are the angles on the unit circle that your y values are 0. And so that is true in two places. That is true here and here. So two possible angle answers are at both 0 and pi. If I solve the second equation, I have sine x equals positive 1. So where are the y values positive 1? Well, there's only one place that that's true, at pi over 2. So there are three answers to number 9, 0, pi, and pi over 2. Number 10, my goal is to, again, try to get this all in terms of the same trig function, or at least somehow replace an identity in some way so that we can work with this a little bit more. Now it looks like we don't have any, like this is a term and this is a term, and there is no GCF right now. What I do have in this problem, which is something that is on your identity sheet, which is helpful to use but we haven't technically studied yet, is this identity right here. So let me pull up the identity sheet, sine 2x. Let me find that. So sine 2x, the only reason I have it here is just to use it for this identity. Sine of 2 theta is really equal to 2 sine theta cosine theta. Because we have not studied this, this would not be on your test, a problem exactly like this, but it's good just for the practice anyway. So what I can do is replace sine 2 theta with 2 sine theta cosine theta. So let me do that. So this is really 2 sine x cosine x. The reason I want to do that is because I want all of my angles to match. We have a single x, and a 2x, but if I use the identity, everything is in terms of x. So that's what I replaced, but it still has the sine x minus cosine x equals 0. Now that I've replaced this identity, now there is a greatest common factor. Between this term and this term, I can take out a cosine of x. And if I do so, I'm left with this. I'm left with 2 sine x times another sine x minus 1 equals 0, which is the same as 2 sine squared x minus 1. Now, I can use the zero product property to set both of these equal to 0, like number 9. So I have cosine of x equals 0, and I have 2 sine squared x minus 1 equals 0. So again, if I solve these both separately, here I'm asking what angles are the x values 0? Well, there are two places, so let me erase this. The two places that the x value is 0, what angles, would be at pi over 2 and 3 pi over 2. So two of my answers are pi over 2 and 3 pi over 2. If I look at the red piece and I add the 1 over and divide by 2, I would get that sine squared x is equal to 1/2. Now the sine is not alone yet, so I have to take the square root of both sides. So the reason we put this problem on the review is to review this topic in red mainly. So we'd have sine x equals, Remember, when you take a square root, it's really plus or minus. If I take the square root of 1, that's just 1. If I take the square root of 2, that's just going to be left as root 2. But if you think about rationalizing that, that is saying that sine of x is equal to plus or minus root 2 over 2. And that's handy because root 2 over 2 is on the unit circle. Specifically, sine is positive or negative root 2 over 2 at any 45-degree based angle. So I have 4 possible answers: pi over 4, 3 pi over 4, 5 pi over 4, and lastly 7 pi over 4. So this example, there were 6 possible answers. And remember, on your test, we will not be testing the double angle formula because we have not done it yet, but the reason it was here in the review was eventually to get to this red piece to remind you mainly about the plus or minus and the square root. Number 11, please write a possible negative sine function equation for the graph below. So negative sine starts on the midline and then goes down. If I look at this graph and I think about, is there any vertical shift first? I usually start here because if there is vertical shift, we have to draw a midline. So it looks like my amplitude right now is up 1 and down 1, which means that there is no vertical shift. So the midline is going to be my x-axis. So I'm going to write none here. My amplitude is up 1 or down 1, so my amplitude's 1. The period is only found once you figure out what your curve looks like. Negative sine starts on the midline, goes down, back to the midline, up, and then back to the midline again, 5 dots. So this is what we're looking for here. So the period is the distance from the end to from beginning to end. So I'm really taking 5 pi over 4, and I'm subtracting negative 3 pi over 4, which is really adding. So this is really 8 pi over 4, or 2 pi. So the distance from start to end is 2 pi. To find the b value, I know that forwards, the period is 2 pi over b, and that should equal 2 pi. Now some of you might be able to look at this and say that I know that b has to be 1, but you could always cross multiply. 2 pi times b equals 2 pi, divide each side by 2 pi, and we get that b is 1. So in this example, there's a lot of 1s happening. Is there any horizontal shift? Yes. The graph that we chose starts at negative 3 pi over 4, or we're going left 3 pi over 4. So if I wanted to write my final equation, we would have y equals, it's negative sine, so we need a negative in front. The amplitude is 1 technically. Sine, open parenthesis. The b value is technically 1, open parenthesis. We're going left 3 pi over 4, which is x plus 3 pi over 4. And then there's no vertical shift, so that's technically plus 0. Now a lot of you are thinking, do I need to write all this? No. So if I simplify this down a bit, my answer would be negative sine, parenthesis. You could keep the 1 there, but you don't need it. X plus 3 pi over 4, and that's it. Number 12, graph 2 periods of the following equation. Label your axes. All right, so this is a negative cosine function. So eventually we're going to be starting below the midline. The amplitude of this is 3. The period of any sine or cosine graph is 2 pi over b. So in this case, that is 2 pi over the b value, which is 1/3. Before I get there, though, let me rearrange this equation a bit. Let me take out the b value of 1/3. And if I do, I'm left with x plus something. Remember, when you take out a 1/3, what you're really doing is dividing by 1/3, which is the same as multiplying by 3 over 1. So you're really adding 3 pi over 2 and then subtracting 1. So the b value is 1/3. 2 divided by 1/3 is really the same as 2 pi times 3 over 1. So the period is 6 pi. The interval is the period divided by 4, which is 3 pi over 2. The horizontal shift is left 3 pi over 2, and the vertical shift is down 1 unit. So when I'm graphing, I would like to draw my new midline down here at y equals -1. I also would like to start with left -3 pi over 2. So, I'm going to use a different color here. I'm starting left -3 pi over 2. Let me actually undo that and make sure my intervals are a little bit higher so they don't get in the way. So -3 pi over 2. If I start with my horizontal shift, -3 pi over 2, and I add my interval, which is also 3 pi over 2, the reason this is on this review packet is to remind you that 0 counts as an interval, because if I add -3 pi over 2 plus 3 pi over 2, that it lands on 0. Then if I keep adding 3 pi over 2, we would get 3 pi over 2. Then we get 6 pi over 2, which is 3 pi, 9 pi over 2, 12 pi over 2, which is 6 pi, 15 pi over 2, 18 pi over 2, which is 9 pi. Let's check in before I keep going how many dots I have so far, so we can see if we can graph exactly 2 periods. So for this one, if I'm graphing a negative cosine, I need to figure out the amplitude first. So from the midline, I'm going up 1, 2, 3, and down 1, 2, 3. So the highest point is 2, and the lowest point is -4. So for negative cosine, I start at the lowest point here. Then I go to my midline, and remember 0 is included. Then I would go up to the highest point, back down to my midline, and then lowest point. So far I have 1 period. Now again, something that came up on the tests for Cumulative 7 is a lot of you forgot, or maybe just needed a reminder, that this dot counts again in the next period. So if this is the lowest point again, at 9 pi over 2, it goes 1, 2, 3, 4, so it looks like we need one more interval. We need 5. So this was 18 pi over 2. So the next one would be 21 pi over 2. And so that would land down here. And so my second period would look like this. And it's important to notice that if negative cosine starts down here, after 2 periods, it should land in the same place. So this would be your graph of the negative cosine. Graph one period of the tangent function. And if I do that, remember it says vertical stretch, not amplitude, because a tangent function doesn't have amplitude because it goes on forever to positive and negative infinity. But the vertical stretch is in the same position. It is 4. For tangent, the distance between the asymptotes isn't 2 pi, it's pi. So the period's pi over b, which in this case would be, let me rearrange this equation for tangent, take out the b term of 2, and you're left with x minus 5 pi over 2. So the period is pi over 2, which means that the intervals are pi over 2 divided by 4, which is the same as multiplying by 1/4. So it looks like you're consistently going up or down by pi over 8. It has a horizontal shift. We're going to the right 5 pi over 2, but it does not have a vertical shift. But it does have, actually, and it doesn't even have a reflecting over the x-axis, so it's going to be a positive tangent function. So remember, for tangent, you would like to start with the horizontal shift. So I'm going to draw my y-axis here, and I'm going to put 5 pi over 2 right here. Now tangent, you need to go 2 intervals in each direction, and these are going to represent your asymptotes for 1 period. And so what you're doing to 5 pi over 2 is you're adding pi over 8 each time. If I get a common denominator with that, I need to multiply this by 4 over 4. So that's 20 pi over 8, and I'll write that up here just for reference. And I'm adding pi over 8. So that would be 21 pi over 8, and then 22 pi over 8, which is really 11 pi over 4. If I go the other direction and I take 20 pi over 8 and subtract pi over 8, that is 19 pi over 8, and 18 pi over 8, which is really 9 pi over 4. These two are going to be my asymptotes. The vertical stretch is up 4 and down 4, and because your graph is increasing, this would be your lowest point, this is your middle, and this is your highest point. So your graph is going to look like this.